Hello everyone, and welcome back to another remote sensing lecture video. And in this video we're going to pick up where we left off talking about this idea of electromagnetic radiation. So in the previous video we drew a couple diagrams that described this idea of the electromagnetic wave, and we discussed sort of three critical terms: wavelength, speed, and frequency. So if this diagram is new to you, or if you have any questions, I encourage you to go back and watch the previous video. But what I want to do now is I want to take these terms and give them some units, in the case of speed, give it a constant, and begin to sort of wrap these up in some pretty important mathematical relationships that we can use to make predictions about things. So first of all, let's go ahead and give ourselves a little bit of more space here. And let's go ahead and write down our terms. So the first term that we had, was speed. That was speed. And we said that speed was the speed at which this wave traveled through space. And the nice thing here with the speed is that it's actually a constant value. So what we can do here is we can actually just go ahead and set this to a constant value. And in case you're not familiar with the speed of light, right, let's just go ahead and say this is the speed of light. Right? So the light will always travel at the speed, this wave will always travel at the speed of light. And we know from measurements that this is 2.99 times 10 to the 8th meters per second. Right? 2.99 times 10 to the 8th meters per second. So what I want to do here is I want to sort of anticipate that we're going to be using this in some equations, and I want to give it a sort of variable. We're going to use the letter C in the future to designate when we're talking about speed. The next thing we had was wavelength. Right, it was wavelength. Right, and we said that wavelength was the distance from one crest to another crest. And we measure this in nanometers. Now, nanometers is approximately 10 to the 9th meters. So this would be 1 times 10 to the negative 9 meters. So nanometers is a really short distance, and this is the primary unit that we're going to be using to measure wavelength in. And when we look at equations, we're going to see something that looks like this. So this is a special Greek character that we call lambda. Right, so this special character lambda, this is going to be the variable symbol that we're going to use to talk when we talk about wavelength. And then finally, the third term that we had was frequency. And frequency, again, was the number of peaks that pass by a particular point over a given period of time. And this is typically measured in a unit called cycles per second. Or other words known as hertz. Right? And if you're familiar with sound, hertz will be a familiar term to you. And in terms of the variable notation that we use here, you will typically see this, it looks like a V. So, just to recap, we have speed, which is the speed of light. We have lambda, which is measured, or we have wavelength, which is measured in nanometers, and we have frequency, which is measured in hertz or cycles per second. So what I want to do now is I want to generate 3 equations that relate these 3 terms to each other. So equation 1 let's use a different color. So equation Equation 1 is C equals lambda. That's a terrible lambda. Let's try that again. C equals lambda times V. So what this is saying here is that the speed of light is equal to the wavelength times the frequency. And that's what this equation is saying. Right, this is the speed of light. Speed of light is equal to the wavelength times the frequency. Right. That's what this equation here is saying. Is that the wavelength, speed of light is equal to wavelength times frequency. Well, we know for a fact here that this speed of light is constant. So if we change one, we have to change the other, so that no matter what, this equation holds true. And C is always a constant. Actually, let's just make sure that we remember that this is a constant. Right, this will never change. So we can do some rearranging here, and we can specifically rearrange into 2 other important equations here. So equation 2, we can solve for wavelength, right? We can solve for lambda here. And so to do this, we simply divide both sides by frequency. So to make lambda the subject of our equation here, right? To make lambda the subject of our equation, we divide both sides by frequency. So we get C over V. So to put this into sort of English words, right? Wavelength is equal wavelength is equal to the speed of light. Right, the speed, that's terrible. Let's try and make that a little bit cleaner. It's equal to the speed of light divided by the frequency. Right, divided by the frequency. Okay. So let's just think for a second here about what this equation specifically means here. What this equation means is that as you increase frequency, right, as the bottom number here gets larger, right, as you increase frequency, this whole thing here becomes smaller because C is a constant. C is never going to change. So as you increase the denominator and the numerator stays the same, this whole thing gets smaller, which means the wavelength gets shorter, which means those peaks are getting closer together. So hopefully that makes sense, that as you increase frequency based on this equation, as you increase frequency, you decrease wavelength. And then finally, what we can do is we can do one more equation. Oops. Equation 3. And so for equation 3, we're going to go back to this, and we're going to make the frequency the subject of the equation. Right, so we're going to make frequency the subject of the equation, and we're just going to end up with the sort of same thing here with the terms flipped. So we're going to end up with C divided by wavelength. That's a terrible wavelength, but let's see if we can make that a little bit better. Divided by wavelength. So this is saying that frequency is equal to the speed of light divided by the wavelength. Oops. G wavelength. So hopefully you see here we have that same relationship, where as you increase the wavelength, you decrease the frequency. Right? As this number gets bigger, again, C is constant, so this whole thing is going to get smaller. So as you increase wavelength, you decrease frequency. They're inversely relationship. Let's go ahead and just end the video here by just highlighting that point one last time, that wavelength, actually let's do it in that color. Wavelength and frequency are inverse, I can't spell inversely, but inversely proportional. Right? Are inversely proportional. Hopefully that makes sense. If any of this doesn't make sense, if you didn't understand one of the equations, I encourage you to go back, rewatch the video and the parts you're confused about, and as always, please reach out. Thank you.